Friends, today we will learn how we can compute seasonal indices using ratio to moving average method from a time series data manually. So here, as you can see, we have data for 3 consecutive years and data is available on monthly basis. Say this data indicates production of a business farm. Now to calculate the seasonal indices, you need the data either daily or say weekly or fortnightly or monthly, 2 monthly or quarterly data, that is 3 monthly data. Beyond that, it would be difficult to compute the seasonal indices, especially for say 6 monthly data or annually data. You hardly have any season to compute the indices. So the data cannot be used for that purpose. Now, we'll do it manually. So first thing that we need to do for this type of data is that we have to rearrange the data in a way in which it can be computed actually from the data set itself. So we require to rearrange the data. As you can see here, we have a rearranged data, same values we have written in a different way, and we have separated the year and the 12 months, and they are all flattened or placed in the form of a column. Then next column heading is the 3 monthly moving total. Here we take the total for the 3 months and write corresponding to the middle value. So we have a value corresponding to February of 2018, and it is the sum of the first 3 values of the time series. Corresponding to that, we have the next 3 values of a time series, that is 28 plus 23 plus 19 equal to 70. So this is the value that we get, and then corresponding to this we get the one value after the other. Obviously you may note that we don't get any value corresponding to January 2018 and December 2020 because they are getting absorbed for computation of the 3-point moving total. Next step is to compute the 3-point moving average. So first 3 values 83, 70 and 59, the average of that is coming here 27.67, which is basically the average of 32, 28 and 23. Now once we obtain these, in the next step we calculate the ratio to the moving average, and that is the actual value corresponding to the time series for the month of February, that is 28, divided by the 3 monthly moving average that we have got in the previous column, that is 27.67, and that is expressed in percentage by multiplying it by 100. So we have 101.2. In the similar fashion we proceed. The next value will be the value or time series value of March 2018, that is 23 divided by 23.33, whole thing multiplied by 100, so that is 98.6. Basically you will get values in and around 100, some values more than 100 and some values less than 100, as you can see. And obviously you will not get any entry corresponding to the first value, that is January 2018, and the last value, that is December 2020. Next we actually redesign the table what we had got in the previous step, and we write it in a horizontal form instead of keeping it in the flattened form. We actually write it in the horizontal form in this way. So these ratios, we are writing it in this way, and as you can see, there is no entry corresponding to 2018 and January, and the last value, that is 2020 December. On doing this, next we come to the create a new row where we total up these values, and then we take the average of these values. So we just take a 2-line computation we have to do based on the data produced in the previous table. First we rearrange them, and then we create a new column, that is one column is total, where we total up and then we compute the average. Remember that for the first entry, that is for the first month, January, we have only 2 values, and so the total is to be divided by 2 in this case, and same for December because we have 2 entries and not 3 entries. So the total that we get is divided by 2 for the first case and the last month, first month and the last month. For the other 10 months, we divide the total by 3. So accordingly, we get this. Next, we take the total of these averages. So it comes to be 1185.81. And then we calculate an adjustment factor since our data is monthly, so it is 1200 divided by the total. If we have quarterly data, it would be 400 divided by total. If we have, say, data on 2 monthly basis, then it would be 600 divided by total. So subsequently for weekly data and daily data. Okay, so it's 1200 divided by total, and that is the adjustment factor 1.012. This adjustment factor is multiplied to get the adjusted seasonal indices. So these averages are basically the seasonal indices, and then we multiply this by the adjustment factor, and so we get this. So corresponding to January, the index value is 111, then February 102. So this way we get for all the 12 months of the year. Now, one easy way to see this and to identify or understand how the seasonal indices are influenced, we draw a simple graph. This is just a line diagram where we see the values corresponding to the different months, and then if you look at the graph, you better understand that, well, there is an initially it drops down and then it increases a bit in May, and then once again it goes down since August. After August, there is an increase that has been noted. That is, in winter months, there is an increase over the things happening in the summer month. But in summer month also, there is a peak in the month of May. So this is how we understand the seasonal impact of the time series. And this is done by the process of eliminating the trend. There are different methods of doing this. Here we had covered by using the method of moving averages to understand the seasonal impact of the time series. Friends, we have another problem at hand today. We had seen earlier computation of seasonal indices using ratio to the moving average method for monthly data. Now let us see what happens if the data is quarterly. So this is the data set we have for 4 different years and for 4 different quarters. So for each year, for the different quarters, 4 different quarters, we have the data set, and we need to arrange them as we have seen in the earlier case, that we have to take it, flatten the data, and then we should start the computation. So let us first flatten the data. Well, we have flattened the data, though here we see the entire computed table, but let us go step by step. So first we write the 4 years, as you can see here, and the 4 quarters we write here. And then we write the corresponding values. Now here there is an issue, small issue is there, and the issue is that we actually take the sum because it's a quarterly moving total. So actually there are 4 quarters, so we take the total for the first 4 quarters together. So for this 2018 we get one data, it is 248, but there is no place to write it corresponding to any particular quarter because there are 4 quarters. Earlier case it was 3 monthly, so it was odd. So we could find a value against which it is centered, but this is not the case here. So we write here in the middle of the second and third. So this way, next we take 60, 54, 59, 86, compute the total, which is 259, and write it corresponding to in between, in the middle of 3 and 4. So we write it here. So like this we go on and we write all the values. So 4 quarter moving total. But since we cannot center it, so we take the sum of 2 4 quarter moving totals, that is 248 plus 259. We write it, find it as 507. We now find somewhere around which it can be centered, and that is corresponding to the third quarter. Similarly, the next one, 259 plus 264, we find it is 523, and we can write it corresponding to the fourth quarter. In this way, we write all these values starting from the third month to the third quarter to the last one's second quarter. So we get these values. We don't get 2 values corresponding to the first and second quarter of the first year and the third and fourth quarter of the last year. After that, we have computed, because there are 8 values actually come up here, 4 in 248 and 4 in 259, and then added together. So basically there are 8 values. So we actually divide by 8 and we get the 4 yearly moving average. So these are the 4 yearly moving average that we have got. After getting the 4 yearly moving average, then we take the original time series value, that is 54, divided by what we have the moving average value, that is 63.3575, and whole thing multiplied by 100, so we get 85.21. Similarly, the next one is 59 divided by 65.375, whole thing multiplied by 100, that is 90.25. In this way we get this averages value. So some values are more than 100, some values are less than 100, so we get the ratio to the moving average method, and hence the name ratio to the moving average method. Now once we have obtained this, we go to the next step, and in the next step we have the rearranged table. That is, we have taken the ratio to the moving averages. Obviously we don't get it for the first 2 quarters at the beginning and last 2 quarters at the end. Then we calculate the total of the values for the all the quarters. As you can see that there are 3 entries only, so we have taken 3 entries, unlike the previous one. Here we have 3 entries only, because 2 are missing at the top and 2 missing at the bottom, so that had made the number of entries corresponding to each of the quarters equal. So we have got this, and then we have taken the average of this. So average 3 values, so divided by 3, so we get the average value. These are the seasonal indices, and then we get the total 398, and then from this total we calculate the adjustment factor 400 divided by total, because there are 4 quarters, so 400. Earlier we had 12 months, so it was 1200 divided by total, but here 4 quarters, so 400 divided by total, so it is 1.003. So these are the seasonal indices, and these are the adjusted seasonal indices average into 1.003. So this is equal to this. These are the values adjusted seasonal indices. So these are the adjusted seasonal indices, and then we draw a graph in order to understand how these varied. And as you can see, the seasonal index shows that it is maximum consumption takes place in the first quarter, and then or maximum production is in the first quarter, then it drops down, and then the last quarter there is a slight increase, though quite different from the peak which is in the first quarter. So this is how we compute the seasonal indices. So we have seen computation of adjusted seasonal indices using the ratio to moving average method, using calculated manually, and for 2 particular data set, once when the data is available on monthly basis, and once again when the data is available in quarterly basis. Thank you for watching the video. Please like, share and subscribe our channel Statisticians Hub.